So today we are going to discuss the very basic fundamental phenomena of inorganic chemistry, that is VSEPR theory. Okay. So in inorganic chemistry, if you want to know the bond angle, if you want to know the bond length, if you want to know the geometry, if you want to know the exact symmetry of the molecule, there is a one special thing. There is one what you can say that a magic theory, which is nothing but your VSEPR theory. Okay, so let us discuss about VSEPR theory in detail. So this VSEPR, 5 letters, has got something, a very unique meaning. So V stands for valence, S stands for shell, E stands for electron, P stands for pair, and this R stands for repulsion. Okay, now each word is very important for us, which determines the exact shape or exact size of that particular molecule for which you are getting or for which you are applying the VSEPR theory. First one, valence. So what is a valence? The number of electrons or the electron that is present in the outermost shell of your atom is called as valence shell. Okay, valence shell means what? The outermost shell of your atom. So valence shell मध्ये जो electron असेल, more precisely valence shell मध्ये जी electron pair present आहे, त्या electronच्या pair मध्ये, now see that this is my electron pair. This is your another electron pair of another atom. This is the valence shell of, let us say, atom A, and this is the valence shell of, let us say, atom B. या atom A मध्ये ही जी valence electron pair आहे, या atom B मध्ये valence electron pair आहे, त्या दोघांमध्ये repulsion असणार आहे. Now this repulsion is very crucial. This repulsion will give the idea of the bond angle which is present in between two atoms. Let us say, consider your water molecule. We will discuss in detail by watching the demonstration or watching the model. But in this particular case, इथं एक इलेक्ट्रॉन पेयर आहे, या बॉन्ड मध्ये एक इलेक्ट्रॉन पेयर आहे. ही जी इलेक्ट्रॉन पेयर आहे, if that is creating some sort of repulsion, that will give me the idea of exact bond angle of your particular molecule. Now, जर मला VSEPR theory बद्दल जरा डीप बोलायचं असेल, what will happen? This theory is applicable only for p block elements. So you cannot determine the shape and geometry of s block molecules or your d block transition elements. This theory is particularly applicable to only your p block elements. So why only p block elements, that we will discuss, but let us go in detail. Now this is my boron family, carbon family, nitrogen family, oxygen family, and fluorine family. So boron outermost or electronic configuration is 2s2 2p1. इथे 2s2 2p2, इथे 2p3 2p4 2p5, इथे 2s2 तुमचा प्रेझेंट असणारच. Now the outermost electrons, if you count, boron has 3 electrons in its outermost orbit. Consider carbon, 4 electrons, nitrogen 5, oxygen 6, and fluorine family मध्ये जेही एलिमेंट्स असणार आहेत त्यांच्यामध्ये 7 electrons outermost orbit मध्ये तुमच्या प्रेझेंट असतील. So why we are considering the outermost orbit electrons? Because these electrons are valence electron firstly, and secondly, this electron only these electrons will participate in the bond formation. So 2s electron and 2p electron, one might think that 2p orbital is outermost orbital. No, जेव्हा principal quantum number same असतो, at that particular moment you must say that these both electrons, although they are different in different subshells, you consider them as a outermost orbit electrons. Now boron family मध्ये outermost 3, carbon 4, nitrogen 5, oxygen 6, and fluorine 7. Now how these particular electrons will differentiate the shape and actual geometry of the molecule, we will discuss. Let us say, consider the hydrogen compounds of these three famous elements. Carbon plus hydrogen will give me methane, nitrogen plus hydrogen will give me ammonia, and oxygen and hydrogen will give me the very famous compound that is water. Now if I want to know the hybridization, number of lone pairs, number of bond pairs, geometry and shape, I must use a theory which we have already discussed, that is VSEPR theory, valence shell electron pair repulsion theory. Now how to find out the hybridization of your compound? Let us discuss that in detail. Now already we have discussed that your carbon has 4 electrons in its outermost orbit. 1, 2, 3, 4. Your nitrogen has 5 electrons in its outermost orbit, and your water has 6 electrons in its outermost orbit. See, this theory is very important. By using this theory, you can determine the exact geometry and exact shape of the molecule, which is very much important to determine the point group of that particular element. So, look carefully. Now, if you can see that I am having 4 hydrogens, म्हणजेच कार्बन मधल्या एक आउटर मोस्ट मधला जो एक इलेक्ट्रॉन आहे त्याच्यासोबत हायड्रोजन मधल्या एका हायड्रोजन मधल्या एका इलेक्ट्रॉनने बॉन्ड फॉर्म केला. सो टोटल नंबर ऑफ बॉन्ड्स किती फॉर्म झालेले? सो टोटल नंबर ऑफ बॉन्ड्स आर 4. मग 4 बॉन्ड्स फॉर्म झाले. इलेक्ट्रॉन्स किती आहेत आपल्याकडे? 1, 2, 3, 4, 5, 6, 7 and 8, and all these electrons, if you want to accommodate in the orbitals, you need 4 orbitals. And star orbitals वाला hybridization होते sp3 hybridization. एक s orbital आणि 3 p orbitals. S orbital accommodate 2 electrons and p orbitals will accommodate 6 electrons. So 6 plus 2, you will get the 8 bonded electron. So in this particular case, the geometry is tetrahedral. Let us not talk about shape at this particular point. We will discuss about shapes after discussing the LSD and OH2. Now, the shape, I will say the geometry is tetrahedral. Now, if you see, the geometry is tetrahedral. Number of bond pairs किती आहेत आपल्याकडे? See, this is your tetrahedral molecule. This one is your carbon and first hydrogen, second hydrogen, third hydrogen and fourth hydrogen. So this molecule has the tetrahedral shape and geometry. But definitely we will discuss about shapes in detail after solving the example of ammonia. Now, in case of ammonia, I am having 3 hydrogen atoms. Nitrogen is having 5 electrons. Okay, so attached 3 hydrogens. Now, these 2 electrons, look carefully, these 2 electrons are as it is there, which will not at all participate in the bond formation, and hence these 2 electrons constitutes a pair which is called as a lone pair, which is not going to participate in the bond formation. So this is your lone pair. Now if you can see that bond pairs किती bond तयार झालेले? 1, 2, 3. So total bond pairs are 3. Lone pair किती आहे? 1. So 4 total electron pairs किती झाले? 4 झाले. या केस मध्ये पण किती होते टोटल इलेक्ट्रॉन पेअर? 4 होते. 4 लोन पेअर 4 इलेक्ट्रॉन पेअर्स अकोमोडेट करायचे असतील, हाऊ मेनी ऑर्बिटल्स विल यू नीड? डेफिनेटली 4 ऑर्बिटल्स, and hence ammonia has sp3 hybridization. So sp3 hybridization असेल तर त्याची ज्योमेट्री काय येणार? Definitely the geometry will be tetrahedral, but there is a twist in the tail. The shape will not be tetrahedral. We will discuss about it. So this is the shape of your ammonia molecule. Isn't it looking like a pyramid? So 1 hydrogen, 2 hydrogen and 3 hydrogen, and this nitrogen has lone pair. This particular lone pair will not at all participate in the bond formation. So what is the role of that particular lone pair? This lone pair will attack on the another proton, and that is why this particular ammonia acts as a good base in so many organic reactions. So we have discussed about ammonia. Now let us say we will go towards the last molecule, that is your water molecule, dihydrogen oxide. Now किती आपल्याकडे हायड्रोजन्स प्रेझेंट आहे? एक आणि दोन हायड्रोजन पेअर प्रेझेंट आहे. सो दिस पेअर and these pair will not at all participate in the bond formation, and hence this is your lone pair number 1 and this is your lone pair number 2. Just see carefully. वॉटरचं स्ट्रक्चर काढल्यानंतर तुम्ही खूप वेळा इकडे एक लोन पेअर असे दाखवलेले असेल. सो these lone pairs are this. Now if you can see that bond pairs किती आहेत बरं? In this particular case the bond pairs are 2. लोन पेअर्स किती आहेत? 1, 2. म्हणजे टोटल इलेक्ट्रॉन पेअर्स किती झाले बरं? अगेन 4 इलेक्ट्रॉन पेअर जर तुम्हाला अकोमोडेट करायचे असतील तर हाऊ मेनी ऑर्बिटल्स यू गोना नीड? यू गोना नीड 4 orbitals, and hence the hybridization of water is also sp3. So the shape is your bent shape or the shape is your angular shape. Okay, can you see this? So this is your oxygen, this is lone pair number 1, this is lone pair number 2, and this one is your first bond, and this one is your another bond, which will give you the bent shape or V shape or your angular shape. Now just discuss about your shapes in one more minute and then we will move towards the another part. जर lone pairs 0 असतील, परत मी लक्षात घ्या, जर तुमच्या मॉलिक्यूल मध्ये लोन पेअर जर 0 असतील तर युअर जॉमेट्री विल बी इक्वल टू युअर शेप, and hence in case of methane the geometry is tetrahedral and the shape is also tetrahedral. Now in case of ammonia, geometry is determined on the basis of hybridization. Hybridization जर sp3 असेल तर geometry आपण काय सांगतो? sp3, and that is why the geometry of NH3 is also tetrahedral, and in case of water it has also got the tetrahedral geometry. But due to the presence of lone pairs we can say that geometry is not equal to shape. तर ह्या केस मध्ये sp3 अमोनियाच्या केस मध्ये आपण geometry काय बघितली होती? So the geometry is tetrahedral, and hence on the basis of that we say that your ammonia has got the pyramidal structure. And what about this? What about your water? What about your dihydrogen oxide? Water, the geometry is tetrahedral. Why? Because geometry is given on the basis of your hybridization. Hybridization is sp3, so the geometry is sp3, and the shape will be V shape or the bent. So that was all about the fundamentals of VSEPR theory. In our next lecture, we will discuss about the higher geometries of, let us say, coordination number 5, 6 and 7. So thank you so much. That's all for today. Thank you.